This is the Chem 1 lecture over metallic bonding. So far, we've talked about ionic bonds and covalent bonds. So ionic bonds are formed between a metal and a nonmetal, and we know it's a full transfer of electrons. Then we talked about covalent bonding, that's a bond between a nonmetal and nonmetal, and that's sharing electrons. So what do you think metallic bonds are made up of? That's right, these guys are made up of a metal bonded to a metal, or all metals. Now, and this is a very different situation because metals we know have low numbers of valence electrons and they're looking to give away their electrons. It's a little bit different. When you look at your electronegativities of metals, the difference is really small, so electrons aren't going to be shared. So they don't readily attract electrons. They're not looking to gain those electrons. So they're sharing in a very different way. Like covalent sharing, hey, because they both want electrons looking to gain. You end up with this sharing of electrons with metals that are kind of like extra. There's just extra electrons floating around. So the atoms achieve more stable configuration by sharing valence electrons with other atoms, but there are all these extras. So it's considered to be a sea of electrons, and you'll see that written in lots of different places if you look it up in a textbook or online. Metallic bonds, they always refer to this analogy of a sea of electrons. It's saying, hey, all these extra electrons out there, and it's more easily, they're all able to be more stable, the octets, by just kind of having them out there around. But those free floating, those free electrons are what gives metals those properties. If you picture a piece of metal, silver, aluminum can, those properties of metals are all properties of metallic bonds. So these are that you're probably already familiar with, like luster. That means that they're shiny. Other ones, that means they're malleable and ductile, and these are both terms you've heard before. Malleable means that you can bend it and it doesn't break. Ductile means you can pull it into thin wires. It's flexible, and that's because you've got those extra electrons hanging out that are able to kind of help this mold around. So you can see that this little bar is getting pushed into the metal, and the metal's able to like form around it. They're able to conduct heat and electricity in the solid state. So if you remember, ionic substances had to be dissolved. Because ionic substances, we do have that positive and negative, but they're not free moving. So it has to be dissolved in water, right, in order to be able to move around. That's different. Metallic bonds have those free moving charges. So it can actually conduct heat and electricity in the solid state. That's different than ionic. And last, they don't typically dissolve in water. This shouldn't be surprising. Metals don't really dissolve in water. And they are typically more dense. So they do typically sink in water, and they have extremely high melting points.